To sustain them for a little while, and there's lots of pizza coming in about just under an hour. So we've got a themed night tonight on Elasticsearch, sorry. And we've got David Kemp first up from REA, who leads their search team there, followed by John Charles. So great topics, lots of questions to be thrown at them. Anyone who's trying to grapple with using Elasticsearch, I'm sure we'll get lots of answers tonight. So thanks again to both of them, and we'll start with David talking about how things are done at REA.
Hi, yes, so I'm David. I've been at REA for a couple of years now. We're a big company. We've got sites all around. You're all staring into the sun. Companies all around the world that we own, mostly all in real estate. But our biggest is still our Australian site. Most of you will have perhaps heard of Real Estate .com.au. So that's our bread and butter. That's where most of our revenue comes from. I'm not actually the lead. Yeah, I'm sort of one of the leads.
Why not? I'm sure the other leads are watching on the webcam.
So we help people find real estate listings. Most days in Australia, there's a couple 100,000, up to 400,000 properties for sale or rent. Probably, actually, I've never checked the count for rent, which is probably even more in total. But most of our data is actually history, like it's all the old listings. Because people like to look at the old listings, see how much houses sold for in the past, helps them figure out perhaps an idea of how much a house is worth today. And we've got millions of those. We also help people find agencies, because they'll be looking for someone to sell their house or to manage their rental property. And there's thousands of agencies in Australia. We even help people find individual salespeople and agents, because people actually want to see how many houses has this agent sold that are like mine. And so that's quite a useful thing to provide as well. We've got over 100,000 odd agents in our system. I'm not sure if they're all active. I forgot to check that, but it's certainly an awful lot of data in the system. Although, I mean, in the end, that's actually not a lot of data. Even the millions of listings, when you compare to some places that are dealing with their terabytes of log data that they're analysing, it's actually not huge amounts of data. And even the rate of updates isn't all that compared to a lot of people. We get like dozens of updates per hour, typically quite a few dozen of updates per hour, but it's not really a huge rate of update, except occasionally, in fact every night at various times in the middle of the night, an agency will suddenly upload all of their currently active listings at once. But again, it's just a few thousand that come through at once, and so that's not really a terribly exciting sort of problem that you need to deal with. This, I think, is fairly exciting. This, I think, it's a pretty big number. We have to deal with more than 200 searches per second as people around the country. I'm just staggered at how much people are actually using the site, constantly looking at. I think a lot of them just want to look at kitchens and things to get an idea of how they want to outfit their kitchen. So yeah, it's actually quite a. So this is a big challenge that we do actually have a fairly, what I think is a fairly good research. Again, it's not all that huge compared to some of the big companies, but it's certainly bigger than most places I've ever worked at. I'll give you a quick rundown of the, well, I know the theme's Elasticsearch, but we're not just using Elasticsearch. Certainly all our historic data is in Elasticsearch, those millions of listings. Unfortunately, all of our currently for sale and rent data is still in Microsoft Fast. Over the coming months, we're going to move that to Elasticsearch. I was saying that a year ago, but we're doing it for sure now. The project actually starts it started this week, just gone. All our real estate agencies and agents are all in Elasticsearch as well. Even our auto-suggest, so when we're auto-suggesting suburbs and addresses, that's all coming through Elasticsearch. All of our new stuff, all the Elasticsearch stuff we're hosting in the Amazon Web Services Cloud. We're not actually using the Amazon Elasticsearch service. We're hosting our own Elasticsearch service in Amazon. When we started, they didn't even have the service available, and there's various restrictions of their service that Beck could probably tell you all about one day, but that we're not quite willing to jump onto their service just yet. So this is, those of you who've used the site a bit, this is actually the page that the sold site looks like, because that's been refreshed in the last 6 months. You'll have seen something like this. Basically, it's pretty simple. You can put in suburb, or a region, or state, or postcode, or even what we call precincts. You can even type in an address. You won't get auto-suggested an address, but you can actually type in an address or a street name. You can select properties, like we've got houses, units, number of beds, bathrooms, and so on. Even keywords, so you can say, I want houses where the words polished floorboards appear somewhere in the text. So yeah, as I said, there's suburbs, region, state, postcodes, and so on. We also support geospatial searches, mainly for the map pages. That's, at the moment, it's pretty simple. One of our things that's on the to-do list is allow users to actually draw the bounding boxes that they want, or the polygons that they want, but that's down the track. Our biggest focus at the moment is just getting ourselves off the old technology onto the new. And while we're at it, perhaps adding a few new things, but the focus is just, we have to get off Microsoft fast soon, because they're going to stop supporting us soon. So yeah, we can of course filter by price ranges, bedrooms, bathrooms, car spaces, and keywords. So keywords, I want to talk a little bit more about that, because that's slightly more interesting than the other filters. Mainly because we want to, you know, if we put in something like garden, and it will still match gardening. So we want stemming and stop word filtering when we're doing that sort of that matching. We're just using the Elasticsearch's standard English analyzer. Fine for our purposes, that's fine. We also match against, okay, so agencies can select from a fixed set of selections of what the property type is, whether it's a house or a unit or whatever. There's features like, again, there's a standard list of features where they can tick boxes saying it's got ducted heating, or it's got a sauna, and various things like that. And we want, when people type in keywords, we want to match against those. We found that, firstly, agencies aren't using this a lot, but when they do use it, we want people to be able to search on it. And users, with the old parts of the site, the users can actually select these from the drop down. But again, we found they get a better experience if they just typed in the keywords. We even let the keywords match against addresses, because sometimes people, if they don't realise they can type in a street, if they put in the name of the street that they're really interested in as a keyword, that matches as well. And there we thought, oh, let's include synonyms on street type. So you can put ST or street, and they'll still match each other. And phrase matching. We wanted, if someone did a search for, what's the example I had? It's like, you know, ducted cooling. It didn't want it to match a description that had ducted heating and evaporative cooling. It's what the best use there. It would be nice to have phrase matching there, so you didn't get false matches. At the moment, it's purely filtering. We're not doing any sort of ranking by how good it matches, which is one of the reasons we've gone very light on the synonyms and fuzzy matching or anything like that, because then you would be letting through matches that aren't all that great, and without sort of ranking the better matches above the not so good matches. All the ranking at the moment by default, your ranking is based on the product the agency has actually bought. So you know, the premium listings come up first, and then ordered within that by date and price. The user can then override that. They can actually say, right, I just want it sorted by date, or I just want it sorted by price. One day down the track would be nice, again, although initially, because this is how we make our money really, is to allow agencies to just differentiate themselves by buying premium products. Eventually we'd also like the user to say, well, just rank by the best match on these sort of keywords. That's still experimental at the moment. What I suggest, so I mentioned that this is driven through Elasticsearch. So our homepage, you can start typing in, even misspelled, like here I misspelled Brunswick, started with an N. And we still won't be able to auto-suggest even if there's a little bit of misspelling there. And other parts of our site, we suggest things like addresses as well. But the core part of the site is this, and this works. In the end, again, this was a system we migrated from an old system that was just purely based on Lucene. I mean, it was working perfectly fine, but we decided that we were trying to standardise all our search on just a single technology. The way this works, we copied pretty much what we were doing in the old system, where all of the suburbs, we use what's called the edge n-gram analysis, where the entire string, we don't tokenise it, we just take the entire string. We actually lowercase it. I should have said this mistake there. So the best, we do actually lowercase the string and strip out some of the characters you want to ignore, like apostrophes and commas and things like that. And then we index all the prefixes of the string. Sounds like a pretty crazy thing to do, but it actually works really well. But we also want to be able to match if someone starts typing from within the middle of the word. So we use, as well as the simple indexing from the beginning of the string, we have a separate indexing using n-gram analysis, which does all the prefixes from anywhere in the string. And we find for various types of suburbs, if the user can, like if the user can't remember if it's East Brunswick or Brunswick East, they can start typing from the middle, and it will match rather than us having to ingest those variations, which is another option that we probably should have considered a bit more seriously, but that's
Unless you had auto suggest out of the box, but this is different, right?
We'll talk about that in a moment.
Okay.
Yeah.
So if it is Brunswick East and they start typing East Brunswick, will it match? Or?
It will eventually, although there'll be all the other East
Right.
match first.
Yeah.
But yeah. Well, actually, no, I think that, yeah, it'll only match as far as it still matches from the middle of the string.
Right.
And then as soon as they start typing stuff that doesn't match, then it won't. But at least I'll get prompted saying, hey, I can actually select that. We've got, so there's about, if you include all the postcodes as well as the suburbs and things we're calling precincts and regions, there's about 19,000 documents. The index size, because of all that indexing, ends up at about 59 megabytes in size. Takes, I can't remember now, it actually takes a good 40 odd minutes, I think, to ingest it all. I think initially when we weren't doing a lot of anyway, I can't remember, I think it's about 40 minutes to ingest it all.
And what are precincts things like in and north or something like that?
Yeah, they're terms real estate agents use for their, like to talk, they're within a suburb, like the parts within a suburb. I can't remember exactly.
Sorry?
Westgarth?
Yeah, but they're part of a suburb as opposed to a cluster suburb.
Yeah, they're part, typically within
Okay.
a suburb
That's more
that people commonly, they're not like an official government.
Yeah, right.
suburb.
Yeah,
It's
sorry.
harbour side.
Yeah.
So Westgarth is a part of somewhere north Kent or something?
Yeah,
Yeah.
So then they're just treated as if they were.
Treated as if they were a
Okay.
suburb.
Yeah.
But they're not an official government.
No,
suburb,
sure.
And the real estate agencies like to advertise it
Yeah.
as that under
Yeah,
that
yeah, of
name.
course.
And yeah, I've actually always been really impressed. It's just how fast this is. I mean, we get millisecond response times with this. And with the ranking of that, we'll do like an exact match from the beginning of the string, followed by any sort of match from the middle of the string. Again, exact match from anywhere in the middle of the string. And then finally, we do fuzzy matches from the beginning of the string. And within each of those groups, we then further sort by popularity, which is, some time ago we did an analysis of how frequently people searched on different suburbs, and that's sort of just a weighting that's given within each of those groups. So we also suggest addresses. There's parts of the site where you can actually search individual addresses, because we have a page for every single property in Australia with various information. Even if we don't have any sales history for it, we still have information about that property that we get from a third party. We even have things like the energy store and stuff like that from the third party. So we want to suggest that, again, using Elasticsearch. But for this one, we found the n-gram approach didn't really scale. There's mainly because there's 11.5 million odd addresses, so it's a much bigger document base, and the addresses are much longer as well. You know, a full address is, of course, includes the suburbs, so by definition it's a much longer string. So that didn't scale too well. The other thing was because we were doing the edge n-gram and n-gram analysis on the whole string without tokenizing, because you want to sort of match the whole string from the beginning. You couldn't do synonym matching. Synonym matching you really need to tokenize first. Beck's mentioned to me just this evening there's a filter that lets you combine things after tokenizing. So that
But it's not part of the default.
It's not part of the default. So that's something we could have investigated. But anyway, we haven't gone with this approach. Instead, we're using completion suggestions. And this is something I wanted to explore with the suburbs as well. But initially we just said, let's just do like the old system. But the addresses, we said, let's use the completion suggestions. So this is a feature Elasticsearch has. It's built on top of something I believe we've seen actually offers. And it's purpose-built for auto-suggesting. So instead of using inverted indices, it's actually built on a sort of a finite state machine, or what they call finite state transducer. It has support synonyms out of the box with some problems I'll mention in a moment. But they're very, very fast. So we've got 11.5 million addresses. The index size is actually much bigger. The reason that index size is so big is because of the synonyms. Somehow the synonyms blew out the index. And without the synonyms, I should have actually looked up how much, it's a lot smaller without the synonyms. Somehow the interaction of the synonyms with the way that completion suggested builds up, it's, you know, it's sort of
because it
quite a
basically,
state tree.
for every term it has a synonyms, that's why.
Yeah.
And this is also for the default approach in a country, so it's the way, like, the way to solve synonym is at the indexing time, because don't have any trouble with phrase synonyms. Yeah. So if you do it at the indexing time, it's much better, and also because of the same idea, if they use it at a quick time, then they have multiple synonyms, and then it starts to get nonsense result.
Yeah.
They don't, okay, let's make it at the index side, but.
Or is that the index?
It does, yeah. And I think if you've got multiple terms in your string that are being expanded, that just sort of multiplies together, so you end up with lots of different combinations. So the tree of this finite state machine ends up being quite large. So in the end, it's like, I'm not sure it actually blew out to possibly blew out to be almost as big as when we were trying out the n-gram analysis. And this actually caused us really big as well. Okay, it's still very fast. I'll mention some of the limitations. So it's memory hungry, and with a 56 gigabyte index, it actually holds a lot of that finite state machine in the JVM heap. So we ended up with quite large JVM heaps. Whereas normal indices, they try to keep as much as possible out of the heap, and I think it makes use of, like we've seen, makes use of memory map files, or some sort of thing that lets the operating system deal with the caching as much as possible.
You said you're running these on EC2 instances?
Yeah, these are fairly large. Well, we've got 5 of them each.
So sharded across
Yeah. in the end, it's still like, I don't think all that 56 gig is actually kept in memory. It's still like, I think it's a subset of that, because we certainly don't think we've got 56 gig a heap across the total. But even so, we were finding even with, I think about 8, maybe there's 16 gig with 8 gig allowed, 8 gig given to the JVM. We ran into garbage collection pauses as well, which is big heaps,
Yeah.
especially after a big feed. For some reason, there had been within 10 minutes or so of doing a big refeed of everything, there was then a garbage collect pause, and sort of fine-tune, cut back the size of the heap to try and reduce the garbage collect times. Because especially with an auto-suggest, a garbage collector with several seconds is noticeable when someone's typing along. As I said, the synonyms and index time can blow out the size of the index. But what we found, if you instead of doing synonym transformations at index time, if you do it at query time, it can, for some reason I never got to the bottom of it, can blow out the time it takes to do the query to several seconds. Like, it was just quite bizarre. So we end up just getting a balance where we don't do any synonym matching at query time. We just translate all our streets to their, all the street types to their street abbreviations and full form, and the street suffixes like north, south, east, west, all that to their abbreviated and full form. All that's done at index time, and we just didn't go too overboard with all the different synonyms. We just sort of limited it to all of the major ones. And the compromise seems to work quite well. There's also, we found that, for various reasons, we figured when people are typing in an address, they're more likely to be misspelling, say, the street name, and be annoyed if you start returning addresses with a different street number to what they've typed. So we thought, we really should try and avoid fuzzy matching on street number, which is a bit of a challenge for this, but they tend, you could actually, there are ways of doing this sort of thing. The other problem with completion suggesters, and probably one of the big ones, is that you can't actually specify sort order or query time. You can't sort of do any sort of, all the weighting is determined at index time. When you index all, so when we index all our addresses, we want any sort of sort order to come out from the order suggest, we have to specify that while we're indexing. Even with fuzzy matching, the fuzzy match was just as likely to come up ahead as a exact match, which is really annoying. I think with version 5, when I was playing around with the latest version of Elasticsearch, they somehow changed that, so now exact matches do come out ahead of fuzzy matches. But version 5 only came out about 3 weeks ago or something, so we're still on the previous version. And the way we worked around that is just do 2 queries, one exact and one fuzzy, do them both at once in a single request, and just put all the fuzzy matches after the exact matches. And that seemed to work really well. One last thing I want to talk about is search quality. And I guess the main thing here is we probably don't measure it enough, not as much as I'd like. Part of the reason is a lot of our ranking and sorting is really defined just by our product, so we don't actually have a lot of room. So our first, given we're migrating from old systems to new systems, our first thing to actually measure is how we actually compare. If we're getting different results from the old system, we want to know. So that's a very simple way of measuring, even if it's, I guess, that way we know at least the quality is the same as the old system. It might not be great, but at least it's not worse. We've had a go at using goal sets where we have like a list of about 100 odd different sorts of queries that people do, and even with the auto suggest, here are some text that they've typed. Here is what we think they would probably like to come up first, or at least within the top 5. We've had sort of mixed success with that. It's a sort of an approach I picked up when I was at Census on my pages. We were using goal sets there. Probably not as appropriate for what we're doing, but yeah, it's one of the approaches we use. And just measuring usage itself gives you an idea of how if people are actually making use of the auto suggest and they're just ignoring it, then I mean that's partly a user interface concern as much as the actual search. But yeah, at least that gives us a bit of an idea of if the thing they type, how many letters they had to type before the auto suggest came up with what they wanted, things like that. And consumer sentiment surveys. For some reason, we seem to rely on those quite a lot. I'm always a little suspicious of surveys, but
I've just started doing your survey. I've been looking at the site, and it popped up the thing. I thought, oh, well, bugger, I'll look at this survey as well.
Oh, good. Thank you. Yep, there's lots of people listening to it out, so which is good. But yeah, so we do. I mean, I'm not suspicious, but the company as a whole takes them very seriously, and like our department cheers whenever the points go up, and people start getting worried when the points go down. And yeah, as I said, I certainly would like to spend on this, but our biggest focus at the moment is really just getting us off the old platforms onto the new platforms, and then we can start doing more interesting things.
How big is the goal set that you usually use?
I usually only $100. So it's not all that.
100
It's only about 100 or 200 queries per goal set. So yeah, they're not really large enough to have to get anything terribly useful, but it's just a start. The intention is to keep growing them, but yeah, focus has been elsewhere. It's like this. The focus has been, even if we just have something that's like for like from the old system to the new system, that'll get us started, and then you can improve.
Even like you didn't want the user moving from this search result page to the property page.
We do mention some of that. And yeah, I probably should have put that up there, because that is certainly something that we do measure, is that sort of, which page they're on when they finally click through to the property. So yeah, we do measure that to some degree. Just want to quickly go over a couple of other things we use search engines for. One of the most interesting one, but unfortunately the one I know listed out, is our recommendation engine. So this is where we actually recommend to users. Is, you've been looking at these properties, here's one that we think you'll be interested in. And there we build up a model of user preferences. Helps if they're actually logged into the site. You can log into our site to say search it and do things like that. But even if you haven't logged into the site, with cookies and so on, we try to build up a bit of an idea of what your preferences are in terms of how many bedrooms and bathrooms and price range and suburbs. And from that model, we then try to match your preferences against new listings as they come in. And a big part of that's actually using Elasticsearch to some big fancy
query.
Sorry?
Called the quick later, something like that.
Not that one, I'll talk about that in a moment. This one is just using, they just do a big batch every night, because it's just a simple queries. And using a function score query to work out how close your this listing is to your preferences.
So did you measure how is the quality of the recommendations?
Did I recommend? Sorry,
Did you measure what is the quality of the recommendations?
They do. Yes, it's a different team than me, but yeah, REA does definitely. Yeah, we measure that. What they do is it's actually part of. To build up the model of the user, they build up, they measure the engagement the user has with a listing. And it involves, how much they look at pictures, how much time they spend on the listing. Some of this could be telling fibs, but that's what I recall them explaining to me, is a lot of it's their engagement with the individual listing. And then from that they try and predict how much engagement they'll have with future listings, and then compare that with reality. especially like initially they'll when they started though to validate that what they're doing would work, before they even were recommending anything, they would see when a new listing came along, they'd try and predict how engaged they'd be and then measure reality against that. Of course, now that they're recommending listings, it's going to be skewed a bit by the fact that they're recommending. But again, I guess at least they can see, are they even, you know, do they still have that level of engagement in the listings? The other thing is a user can, when they do searches, they can save a search and ask to be notified whenever a new listing comes along. That at the moment is still on that's still on an old system. What I'd like to explore is using the Elasticsearch percolator for that.
Yeah,
because it lets you save searches and then
it allows. Well, yeah, it
Effectively.
allows you to do the save. You can tell Elasticsearch save the query, and then as a document comes in, it's send it. But what it does is you handling the process of getting the matching and send it to the user. It should be business logic. It's not.
Yeah.
So Elastic will give you the ability to do this matching.
Exactly. Yeah.
And what it does is actually it builds another index.
Yeah, it builds an index for the individual.
Yeah, for the individual one.
And like the
And
early
they have-
versions used to run all the queries on that one document. Now it does, but certainly version 5 now there's a lot of optimizations to
And
narrow it down to.
they do rely a lot in the idea, because if you have a lot of queries and then a lot of users and you want them and a lot of documents coming in, then you can imagine these capabilities.
Yeah, like we have a few million searches.
So
at the
a few
moment.
million savings.
Certainly my experiments so far show it should, because we don't have lots. I mean, the rate at which new listings comes in isn't too bad. So, and it doesn't have to be instantaneous sort of notifications. So, my experiments so far show.
Yeah, that's make it easy.
should
It's
work.
not like it's really time. It's then it's in the issue. Otherwise, it should be alright.
So that's possibly going to start next year. We'll be migrating that system, and it's still in a bit of a let's spike a few things out type of phase.
And I guess it's a pretty easy in Elasticsearch because it's all REST API. You don't have to worry much about that.
Yeah. And then of course, log analysis is probably one of the biggest usages of some places of Elasticsearch. They just want to analyze all the application logs. We actually use Splunk mostly for that. Splunk's quite a nice tool. And because of, because I think if REA wasn't making so much money, they would probably investigate alternatives. But yeah, at the moment we're sort of hooked on Splunk for most of our analysis of logs, doing troubleshooting and dashboards. There are various teams, especially in the security group, that have been using Elasticsearch to sort of try and do anomaly detection on the application logs and access logs, which looks like fairly interesting work they've been doing there.
Are you using Kavanaugh?
Yeah.
That would be, most of the people who use code logs, they just like the idea that Elasticsearch provides it out of the box.
Yeah.
Yeah, it's just not very spotty solution myself.
Anyway, that's all I've got.
So I completed my survey and I said I was very satisfied with the service and the talk I was getting by David. So if someone walks up to you tomorrow with a grill on their face, you'll know that they've read the survey. But you couldn't find my house.
You can't find your house.
It hasn't been listed for 20 years. So it's just old
You
data.
need to go to there is the prices site. That's one of the problems with that site is it's disjointed. There is a part of the site which probably has your property on it in the underneath.
So the front part you get was just the current facade.
Property site.
There's one that says
sold.
property something.
Okay.
and
You can select
property
sold,
history or
but
something.
even that was
sold.
now if you go to the sold section, it still won't be there.
Oh, have you ever listed a listing on the site?
It's probably only the last 15 years worth of listings there. So probably, but you have to go to, if you scroll down to the bottom of the page,
It's called price lookup. Price lookup.
lookup.
Read research any property in Australia.
Yeah.
Who provides that? Because it's really strange.
CoreLogic.
It says
CoreLogic provides the price.
Because it's really strange that service. But just a question: how many people do search actually? Like, what percentage that comes to the sum? Because you've got all your, you can fill in the price, how many bathrooms, bedrooms. So you don't actually have to do a search if you go directly to your land area.
I don't know. So there's, I guess, compared to say, if you go straight to the page, it's using that's just doing like a get by ID on our system, whereas the 200 searches per second are actually searches. So that it's specifying a suburb and any other filters there.
Right.
So although with a caveat that 200 per second includes people going to the next page. So it's, I'd actually have to look in Splunk and narrow it down to just those searches that are on the first page.
I wonder, like, I was trying, sometimes I was looking for a home, and when I wanted to use the website, one of the obstacles that I was having is if I want to filter, you have to filter first. You haven't thought about making it faster search, where you actually search and then you filter out. I don't know, was this a comparison, or that's the way it used to be?
Yeah, at the moment it's, again, with a lot of it's like for like, where people are talking about providing a faceted search, something we're going to explore.
And apparently all real estate, all things that have to do with real estate in Australia, many of those sites, they have this, you filter first and then you decide, then you filter, you cannot have this faster search, and I wonder why all of them have this.
Yeah.
I don't know, I thought probably they have come to the idea that's much better, but I don't know.
Now, to be honest, I can't answer that question.
Well, Max, David, you've got us buying it in November 1995, and you've got the previous sale in November 1978.
Oh, there you go.
Pretty long ago data.
Yeah.
Is that accurate? The 1995 one, isn't it?
It's also impressive to look at how much the prices jump on some.
Okay.
Does it say how much you pay for it?
Do you know how often people type a keyword compared to using the different fields?
The keyword filter, now it's been nearly
Yeah.
12 months since I looked at the statistics there. It's not that big. It was only 2 or 3%. But I haven't looked since we made changes on the sold section of the site where it's much more prominent.
Okay.
I believe it increased, but sorry, I don't have the figures for that. But it doesn't have a lot of high use. But again, 2 or 3% turns out to be a large number of people, but it's still, in that scheme of things, it's not big.
So then where do you get the money from? Is it agents paying fees to list houses, or is it from advert placing via third-party supply?
Yeah, most of the money comes from agencies buying products to get their premier listings listed above others.
Straight from the customer.
Yeah, definitely. But we do get a fair amount of revenue. Like, we'd love to get, our team would love to get rid of all those little ads because they slow down the page load and they annoy the consumers, but they do make us a lot of money, so we can't.
So, I'm a heavy casual user.
Sorry?
I'm a heavy casual user. I'm always looking. But the rankings are just seem, so first I guess, do you know what the standard search looks like? Because for me it's, a list of suburbs, price range.
Yeah, I think most of the searches are like that, but I can't,
And then the
Something I
ranking
really
just
need
seems
to
to be, a few placements and then just recency, right?
Yeah, it's so it's sort of, I think there's about 3 or 4 levels of product, and then within each of those they're grouped by date and price.
Right.
But then you can override it and say, just give it to me sort of by date.
Right.
So Polygon search is coming?
That's the plan.
Oh, that'd be cool.
Because there are some suburbs that you really want to split in half.
Yeah, that's the plan.
Oh, you use regions.
So as I said, our big
You use
focus-
regions. You say good half of suburb X.
Yeah. I want this half of Parkville and not that half.
Yeah.
Well, how about electorates? I don't want her as my
That's a good
Well, I
idea.
want my vote to count.
That's the positive version.
That's a good idea.
Well, I mean, adding electorate as a field might not hurt.
That's a good idea.
They would, oh no, they
So
don't
then
follow
we
suburb boundaries.
get a lot of call for school signs.
Yeah.
Well,
Right.
There's all
That's
these sorts of overlays, right? School
Yeah.
zones, electorate, radius from a railway station. I want to think within 10
Yeah.
minutes walk from a
Travel
railway
distances,
station.
yeah, yeah.
Yeah, wow, geo.
School
Point
lines are
of
tricky
interest,
because they're,
yeah.
they're not, yeah.
They're not fixed. They're not exactly
They
fixed.
vary from state to state, and certainly in Victoria, there's the data just
Yeah.
isn't there. People claim to have the data, and then you look, and it's it's not.
Doesn't it
complete.
change like fairly regularly?
Yeah,
Changes.
yeah.
It changes from when you buy to when you settle.
You sound like you're speaking from experience or something.
Where do you live?
God, I'm probably still in the low payments. Okay.
Thanks, David.
Oh, okay. Sorry, it's in company policy. Is the
So, you can.
I get, especially since I'm on camera, I don't know if it's shown by that mysterious USB plug-in. It's actually company policy, not always. USBs be plugged into your laptop.
At least they give you decent laptops.
Yeah, that's not.
Really? No, still good too.
Just as tech talks. Tech talks. Yeah.
So next speaker is John Charles, who's I think currently research manager and solutions architect at Ambiva.
Former research manager.
Oh, sorry.
I've moved on since then.
Oh, thank you.
I've just lined up another job with another company in the knowledge management space.
Oh, okay.
So
you don't want to? I won't keep talking about Ambiva.
no, that's
You
fine.
tell
That's
me.
fine. I'd actually been there 4.5 years.
Right.
I'd made a whole series of contributions, and I just felt it was time.
Yeah.
So this talk is about a product that I was intimately involved in migrating from an old client server technology into a software as a service, cloud-based, web-based, highly elastic solution. The product's called Support Point, and it's owned by a company called Panviva. And Support Point is basically a business process guidance platform. So the idea is that if you are a user of Support Point within a company or an employee and you need to know something about the procedures or processes in the company, you can just ask a question and it'll serve you up a document, and the document will tell you exactly what you need to know. So the whole purpose of the product is to provide guidance information that's short, sharp, succinct, so you know exactly what to do and you can get on with the next thing. It's an interesting product. One of the reasons why I joined the company is because I really liked the business value proposition. I thought, that makes sense. One of the challenges that a lot of organisations face is that, especially large organisations, is there are lots and lots of procedures and processes that drive their business, and they're constantly evolving. And the government keeps imposing all these compliance obligations. So somehow you have to manage all of that sort of stuff. So that's where Support Point, the idea behind Support Point, was birthed some 15 years ago. It really found its place in call centres. And the guys who originally developed, they're all a bunch of C++ boffs. Their worldview was, if you want to make something fast, it's got to be written in glorified assembly. It's got to run as fast as possible on the metal. And I'm sure lots of us can relate to that. The reality is compute power is fairly cheap these days. So the challenge with that model is that at the upper operational limits, you run into problems. So the company, about 5 years ago, decided that they needed to change course. They needed to do something because if they continued to try and push their on-premise client server solution, they weren't going to be in business 5, 10 years from now. People would just slowly start leaving. So I joined the company back in 2012 as a development manager, and I was chartered with the job of building a team and re-engineering the product. So it was a modern web-based, cloud-based, software as a service, elastic technology. So I kind of liken this, the product to the good old days of the Commodore computer, you know. It was a beautifully engineered piece of equipment, but it was highly optimized to the particular hardware that the group had designed. And the challenge with that is they had no way of going forward. And along comes companies like Microsoft. They're focused on convergent technologies. They had a pathway going forward. So the challenge we were faced is, how do we migrate from this, you know, they've gone as hard up the rabbit hole as they can technology, down a particular way of doing things, for very good reasons, to extract maximum possible compute power on the smallest amount of compute resources possible. Well, we had a team, solutions architect. I put together a couple of developers. We employed a couple of developers to join me, and we basically started splitting apart the layers. The first thing we did was introduce a web tier. The second thing we did is, okay, we need to take that old application server, and it's going to have to live for a bit longer. So I'll put an interoperability layer around that, because it's just going to take too much work to decommission that. And then we needed a bridge between the web tier and the interoperability layer. We needed to transition from that old request response model into something that's loosely coupled with well-defined APIs. So we rolled in an orchestration layer with an enterprise service bus and a message bus under the hood. So that gave us that loose decoupling and that ability to scale and that opportunity to veneer the old chatty, low-level, you know, TCP/IP, C++ binary objects across the wire protocol into something that's open, well-defined, and looks like best practice externally. So that was quite a journey that we went through. And by about the end of 2014, we pretty much re-architected the product, and we re-veneered the whole front end for viewers. There are several components to the products. There are people who view content and use it, like in the call centers, and customers and employees on premise. There are authors who actually create content. So there is an authoring process you've got to go through to get that content well information engineered so that it's, you know, very, very targeted, very specific. There's an authoring component to the tool, and there's an editor under that, and there's a whole essentially content management tool that had to be re-engineered, component to the platform that had to be re-engineered as well. By the end of 2014, the architecture was in place. We'd re-veneered viewer. We'd actually worked on editor, and editor, rather than being a fat client editor, was now basically a JavaScript editor. So that was well underway. That was quite a tricky project. Took quite a bit longer than we thought because it needed to run across all sorts of different browsers. And we had to tackle a whole lot of out-of-sandbox issues. And we were able to tackle that, and that's another discussion. By the start of 2015, we were starting to re-engineer the editor and the authoring components. And that had completed by early 2015. We'd re-engineered the whole product. And then the decommissioning of the app server started. So basically the idea of rolling an orchestration layer is to protect us from all of that low-level chattiness of the old application server, so that what we expose on the external side of the enterprise service bus is very well-defined APIs. And we had a semantic adapter layer in the enterprise service bus to handle all that low-level chattiness. The benefit of having that orchestration layer in place is that we were now ready for the decommissioning of the application server and moving all of those discrete services housed inside a single application server process into discrete microservices. So that journey began in late 2014, and that journey is still continuing to this day. The last remaining piece of the puzzle that we needed to replace was the search engine. We actually, and that's basically what this talk's meant to be about, but I thought I'd just give you a little bit of context. About 2009, we actually engaged the services at RMIT, we worked with RMIT, and we developed a search engine for the old product. And one of the PhD students here, I can't was that it was, all that information was stored in memory. And the process that was housing all of that intelligence was a 32-bit process. And some of our customers, particularly Westpac, were actually running out of memory for a 32-bit process. So we had a real problem. So one of the first things we had to do was convert that 32-bit process to a 64-bit process, so that we had some longevity with the on-premise solution. The problem, of course, converting from 32-bit to 64-bit is what happens. You double your memory usage. You remove the constraint of 4 gig, that's great, but you're now using twice as much memory. And in an on-premise product, where you don't have control over the resources, that's problematic. But it still bought us some time. We still had a couple of gig up our sleeves. One of the things we found with banks, and this was a problem for the company going forward, and some of those large organisations, is they redline the products. They run it right to the operational limit. And you have no control over their infrastructure. And then when they hit a limit, they turn around and say, it's your fault, fix it. But you're not allowed to change the code. So that is one of the primary drivers for moving towards a cloud-based service where we could control the infrastructure. And also, the total cost of deployment was significantly lower for the customer. Because every time there was a patch upgrade, and you need to roll out 20,000 fat clients to 20,000 desktops, IBM services would sit there and go, ooh, that's $60 a desktop. That's a lot of money just to roll out a minor patch. So obviously, there were significant benefits in moving to the cloud. The total cost of ownership for the customers dramatically reduced. And it also gave us control over the infrastructure, because in many instances, they were using virtual shared infrastructure and they were running it to its operational limits. And that was a problem. So the challenge we faced with the legacy system was that it was hard-coded. There was no manuality. You got what you got. And it was very, very good. There was no domain-specific query language under the hood, so there was no opportunity for extending the product. You had to rewrite it or add new functionality to the product. So the other problem we had was that it was a single point of failure system. And the problem with that is that if the search engine fell over for some reason, and it did occasionally, you have to reboot, and it has to rebuild all that index information in memory. And that's very time consuming, so the search engine goes offline. So there was no fault tolerance. And it wasn't scalable. So we knew that we needed to replace it. So we started looking around at a replacement technology. And one of the companies we were working with, consulting integration company, a company called Sixtree, which just been brought out by Deloitte, they recommended Elasticsearch to us. So we started doing a bit of research on Elasticsearch, did a literature review, having a look at what its capabilities were, lined up our architectural problems with solutions they provided, and it looked like a really good fit. So I thought, okay, it addresses the architectural problems, at least from a literature review perspective. Let's now wade in further. Let's have a look at the capabilities of this particular search technology. So we started an evaluation process. We looked at it, the interfaces, what its capabilities were, how to use the product, and started to get our heads around what the integration challenges were going to be. And I'll wade into that now. So some of the early questions we asked ourselves as we started playing around with it were, okay, we need to be able to do all the things we can currently do. So these were the kind of questions we went through. Well, one, how do I get my stuff out of my primary data store into Elasticsearch? That was challenge number one. Challenge number two, what structure should that document object take in Elasticsearch? What makes most sense? What should I make searchable? How do we tackle the really thorny one? How are we going to tackle document level permission? And in a minute I'll explain why that is such a challenging problem for us. Can we do highlighting as part of search? Does it handle pagination? Autocomplete? Can we do custom boosting? So, if people like a document, can we use that as a basis for boosting the ranking of the document?
For a particular person.
Sorry?
For a particular person, personalised or overall?
Aggregate. So, And the answer to all those was right. Yes, it was a resounding yes. So then we decided, okay, now we've got to go through some proof of concept. We're actually going to do some serious evaluation. The first thing we looked at was what is an appropriate document structure in Elasticsearch. Given that Elasticsearch is really a secondary system store for our purposes. So we thought about that for a while. I thought about it for a while. And basically, we came up with a fairly simple model. What does the document contain? It contains metadata, and it contains a body. And the body contains petitions or containers. And within those containers, you can have visual elements with all the dressage, or you can strip all that out and just say it's text. This is all the concatenated text within that particular petition. And that's pretty much what we decided. That's how we'll do it. So the first proof of concept was, okay, let's take a really hard look at search, and let's make sure we can do everything that the existing search engine can do, and some more. So some of those questions I raised before, can I search across multiple fields with a common term? Yeah, you can do that, no problem. Can I add a list to certain fields? Because some fields are more important than others. You want to get a match on the name of the document, or in the description, that's probably going to be a higher priority than the bottom. Now, Elasticsearch actually has a very clever way of taking care of that by default. But we just wanted the ability to adjust that some based upon our knowledge of the existing search engine. Can I do advanced filtering? We need to be able to filter by folders, we need to be able to filter by last updated since, a whole lot of other things we want to be able to filter by. And we want to be able to do and filtering, filtering, so we can do all those sort of Boolean type queries. And the answer was yes. And then I'll ask him, of course, can I do dynamic boosting based upon lights or boats as an aggregate? And the answer again was yes. So, proof of concept one, just looking at all the details associated with search, was a resounding yes. So now the next thing was, how are we going to do document level permissioning? And the reason why document level permissioning was difficult is because we don't have a flat earth view. Documents in our system are housed in folders, and that can be nested to any level. And one of the early guys who developed who was involved in the development of the product early on, he had the bright idea of, let's add references or symbolic links. So now we don't just have a tree structure, now we've got a graph structure. So that's challenging. But then add to that our permissions. We have the concept of roles. You can attach a role or a user ID to a document, and a role has permissions. But roles also exist in a hierarchy. And the hierarchy has implicit rules. So if I add a permission to an ancestral role, then all of the descendants actually inherit that by default. Now all of that smarts were taken care of in the previous application server. And we needed to unravel that and try and implement that in Elasticsearch. The challenge, so we've got essentially a parent-child plus friend, a graph structure relationship. Elasticsearch is flat earth. So how are we going to marry the two? That was the challenge. We spent a significant amount of time trying to figure that problem out. Well, one of the things we realised is, before we go to the design phase, we need to make some decisions about what are the key principles that are going to drive our design going forward. And what are our goals? So one of the key principles that we decided upon was that read performance is more important than write performance. In order to get high read performance, because Elasticsearch is every index indexes its own rabbit hole, there are no cross relationships, we need to embellish every document with as much metadata as possible, so that when I actually do the search, I've got all the information at my fingertips that I can filter against. So that's how you get the read performance, but you're going to have an impact at write time, because there's a lot of stuff you've got to aggregate together to actually stamp that on a document. The other thing we decided, after a lot of experimenting, We experimented with parent-child relationships, seeing if we could store permissions against a document and also against its parent folder. But there was no concept of ancestral inheritance. So after experimenting with that for quite some time, we decided, you know what, it's just not good enough. It's not going to work for us. We had discussions with the product managers in the Elastic team over in the States, and they said, we're not going there. You're on your own. What we suggest is exactly what we ended up deciding. Stamp everything on the document. So the other decision is that documents are standalone for permission purposes. So that means I've got to pre-calculate at write time all of the roles and their permissions and stamp those as child objects against the document. So essentially an ACL is the combination of a document, an entity, a role or user, and its permissions or operations that you can perform. That constitutes an ACL. So every document will have multiple ACLs that reflect all the permission capabilities and roles for that particular document. So you can see all of that adds up to a fairly complex update management challenge. But one of the principles that we wanted to leverage is we will tackle write performance through parallelism. If every document is standalone, then one thing I can do is I can update as many documents in parallel as possible. So I can offset that. I can actually improve write performance. It will never be quite like written performance, but there are ways of tackling write performance. One of the other goals that we had is, gee, wouldn't it be great if we could combine not just search, not just advanced search and all that filtering capability, that great filtering capability, and all that manuality that comes with that, but what if we could also combine permission filtering at the same time and get highlighting at the same time? And all of that fits under the pagination capability of Elasticsearch. If I could do all of that, I'm a long, long way ahead. And in fact, if you compare that to the legacy application server, the legacy search engine, it basically, you fire a search at it and it returns all the documents that match that. And then you post-process that and you knock out the ones you don't have permission to see. So the orchestration around it was quite complex. And most of the time was consumed knocking out the things you're not allowed to see. So if we're able to combine all those capabilities at search time, then we're miles ahead performance-wise. And actually it simplifies the whole orchestration. On the update management side, by writing things in code, let's just say I'm at a parent folder or an ancestral folder and I add a permission or I remove a permission from that, it will take some time in the update management system for that permission change to be reflected through all the descendant documents. And there was always the possibility that someone fires a change up here and then a viewer over here fires a request, a search request, and then in that list is a document that they very soon will have no permission to see. So we decided we'll resolve that at viewing time. So at viewing time, you select that particular document, and now you can no longer see it. Even though it's in your list, you'll come up with, you no longer have permission to see the document. So we're able to use kind of a lazy deferral to address that particular problem. So, and the other thing, of course, is versioning. Because Elasticsearch is a secondary data store, we're really only interested in two versions. The published version that viewers look at, and the latest version that authors are interested in. So we don't need to track all of the revision changes in between in Elasticsearch. So by just having those two, it simplified the problem. So that then led us into the design phase. And there were four critical components we needed to address in design phase. How to sync a document, and how to do that in such a way that we could use parallelism to the max. And how I could leverage that capability to do indexing and re-indexing. And then of course search. And then the last one was the update management. So sync one of the solutions architect came up with the bright idea of, why don't we do everything as a building block? It's a great idea. Let's create a sync one orchestration. So the idea there is that we have a get document microservice. I dump a request on a get document request queue. The listener's on that queue. An instance of a listener will fire up and it will service that. Call a very complex stored procedure in the database. Extract all of the documents, metadata, or all of its content. It then repivots that from XML into JSON and then publishes that to the response queue. Then the sync1 orchestration in the ESB picks that up and fires the HTTPS request, put request into Elasticsearch to bang into Elasticsearch. The benefit of using that model is that it allows a high level of parallelism. I can dump 100 requests on the request queue, and then each of those microservices, essentially we used .NET C# app domains, so we could have a process has multiple threads executing the same service, piece of business logic, and then you could fire up as many processes as you like. So that gave us a highly elastic, scalable capability at that level, at the microservices level. And of course, with the broker and the ESB, it is highly scalable. It took us quite some time to actually implement that because we had to navigate all the complexities, all the little grubby details of exactly what's to go in a document. And lots of argy-bargy and discussion around what are we going to put in that document? What are we going to expose to Elasticsearch? But having got that in place and having laid that foundation, the next one was quite easy. How do I do indexing and re-indexing? Well, I just leverage the same thing. I have another microservice that's called via the web tier, an index request or a re-index request. It calls a microservice, get document list. It gets a list of all the documents, and then it just batches them and dumps them to the sync1. So the sync orchestration then just fires up, that whole layer just roars like a dozen V8s. And it just starts sucking from the primary data store and punching it into Elasticsearch. Most of the work was, the bottleneck actually that turned out was actually getting stuff out of Elasticsearch and all the repivoting and manipulation required on the actual document. But we're able to do about 30 documents in parallel with a single node of Elasticsearch.
Sorry, can you provide a relational database?
Have a relational database, yeah, exact kind of database.
So you're doing single document index, you're not using a bulk index for Elastic?
Well,
Yeah, because you're using microservices, right? So
That's
you
right,
don't
yeah.
have to do it at real time. And
That's
the
right.
microservice will just keep getting from the queue
right.
and then fall,
yep.
and then that's all.
But I
that's
thought when we
really
played,
fast.
we could get slightly faster, depending on how you played with the batches, by doing
Look, you
bulk
probably
index.
could. You could probably dump that into a bulk.
Yeah.
Or you could actually batch that. The orchestration could batch those and do a bulk update.
Yeah, there is some tipping point actually where it's.
Well, better
Yeah.
Elasticsearch is if you want.
But you know, you don't know. The thing with these sort of things is you don't know until you actually put the infrastructure in place and test it. So the nervous moment is when you start testing and going, how is this thing actually going to perform? Now, what was interesting about the legacy system is if you needed to re-index the database, the search engine in memory from scratch from our largest clients, it's kept it there.
But
So,
then I guess right now Elasticsearch has is the new re-indexing, is it new data or is it
brand new data. So when you index or re-index, you're doing it from scratch.
Oh,
So this is the whole thing in one hit. So you need to have that to get all the data initially. The reason why that was important is if that was passed, then we could use that as a backup if ever there was a divergence between the two data stores. And as it turned out, with our largest customer, it took about 30 minutes to index their entire database. So that was good. We walked away from that and thought, that's fantastic. Because, if push comes to shove, that's actually a backup mechanism to guarantee synchronization between the two systems. If ever there was a problem in the update management system.
how many cores we have? The Elasticsearch cluster, how many nodes we have?
How many, sorry?
How many nodes?
So we were working on, because we don't have a huge data set, 300 or 400 documents for one of our larger customers. Everything is about cost containment. It's minimum number of nodes. Some redundancy, but minimum. So it's got to perform well with a minimum number of nodes. So we were very happy with the results. Then that led us to the next one, well, search. Search, as I said before, we were able to combine all of those capabilities, which made the search orchestration really simple. All you have to do is basically fire an HTTP request at the ESP, and all it has to do is look up in the database all the roles that you're a member of, and then it provides that as part of the search envelope. Fires the request to Elasticsearch, and it takes care of all the pagination, the permission filtering, the highlighting, all of that sort of stuff. So it made that very simple and blindingly fast. Then the thorny issue of how do we do update management? And again, with update management, we wanted to make sure that we used as much parallelism as possible. So the way we did that is we used the event sourcing model. Effectively creating a virtual event log in the database for all possible events that the system generates. Then we didn't actually do it exactly this way. This was the initial conceptual model. We use a poll timer, so every 5 seconds you go and get a list of all the change events. You feed that into a router. The router then routes that into specific virtual topics. In ActiveMQ, the benefit of a virtual topic is that you can have multiple subscribers to the same event. So that gives you the ability to sync to other data stores or to other services. So what were the different types of events? Well, there are document events, there are folder events, there are permission change events, and there are reference events. And for each of those, you had, again, a highly elastic set of microservices that service those events. So for example, if you change the permission on a high-level folder, that will generate an event. That will be picked up by the permission change, routed to the permission change virtual topic. The permission change microservice will then go, oh, okay, let me get a list of all my immediate descendants. If the immediate descendants are just documents, well, the immediate descendants which are documents get synced in their folders, posted back as an event to the virtual topic. So then it recursively, the benefit there is it recursively walks down the hierarchy using that model. And the reason why you want to do that is because recursive queries in a relational database are extremely expensive. So you don't want to recurse, you don't want to use recursive sequence, you want to avoid that where possible. If you just do one step at a time descent and feedback, then you've avoided that the nasty recursive sequence problem. We spent a lot of time thrashing this one out to make sure we got it right. And we gave the developers some flexibility so they could make improvements in development time. It actually went very quickly. They did it start to finish in about 6 weeks. And the improvement they made is, instead of this being a poll-driven event sync, they were able to make it a push-driven event sync. Because in between the existing legacy application server is the central source of truth for all events. They actually do get posted back on a time base back to the database, but we could tap into the app server and post events from there to an event queue, and then the rest of the system took over. So the benefit of that is that even if you did something crazy like change the permission on a group right at the top, this would roar into life and would update, make all the changes all through the whole system. But if there was a bug or an issue, we always had the backup of we could reindex the log, because this is not the primary data store. So that actually worked very well. And all of the effort and gnashing of teeth and endless discussions were well worth it, because the implementation time went very smoothly. Autocomplete's a very important part of our product too, and we did some analysis on autocomplete. And the thing we found really interesting is there's these different types of autocompletes. There's your traditional autocomplete, where you get phrase hydration, all that sort of stuff. But there was also this results-oriented autocomplete. And for a glorified content management system, that actually is really attractive. I don't want to hydrate a phrase based upon stuff in the metadata. Wouldn't it be better just to give you results that match on that? So we use the n-gram suggester to do that on the metadata. But then the problem that introduces in that it's possible that you could actually be matching on stuff in the content. So at the end of the day, what that does is it fires a query. So all we did was add highlighting on the content to that query, so that we had full coverage. So at full coverage, results are in autocomplete. So as you type, it actually gives you a list of documents that match what you're typing. Now, what we also did is we ensured that you don't fire that on every keystroke. You fire that on the pause. Otherwise, it just gets too noisy. So we're very happy with what we're able to do in terms of autocomplete. And lastly, the last one, which you just mentioned, was the reverse search. One of the key features of our product is we have the ability to do essentially a screen scrape of what's going on your desktop. And we fire that with the legacy search engine, and it comes back with a list of documents that match that. It's a bit hickory-jiggery, but basically what it does is does a screen scrape, applies a series of filters to that document, and then finds documents that match the tags that drop out of that. But with Elasticsearch and their percolation capability, we could actually do that. You could register queries against documents that are regular expression type queries. You could do the screen scraping, serve up the information to that, it exercises the queries, if the regular expression matches, bang. That's a hit. So that worked again. So look, I think the conclusion for us was that everything we looked at with Elasticsearch worked. Yes, there was much gnashing of teeth and a lot of discussion around how to do document permissions, particularly given our very bespoke hierarchical permissioning system with all these implied rules. But at the end of the day, we're still able to do it. We're able to address all the architectural issues. We now have in place a very malleable, future-proof search engine, wonderful query language under the hood that gives us enormous capability. We're able to do all that combined search term matching, highlighting, permission filtering, and pagination. So there were tremendous performance improvements doing that. And we were able to address the last issues. So, that's one of the reasons why I'm a big fan of Elasticsearch, because it really worked for us. Some of the other things we started looking at were, just as my colleague was talking about, was using the old stack for platform analytics. In fact, Martin over here was involved in a project doing that for us. He was subcontracting to us at the time. The other thing is using Elasticsearch as an event store. I know there are other technologies that can do that, but Elasticsearch does it, and it does it really well as well. With an event store, you basically want to store the minimal amount of information, and it's typically IDs. But once you've got all that information stored, you can add orchestrations at the orchestration layer, hydrate that information with, convert IDs to names, and you can hydrate it with other information from the relational database. So you can do some very rich analytics with very rich data. So you can do things like, well, who's using, there's a documentation campaign just published, who's actually looking at the documents, who's not looking at the documents. So that you can manage the system. And a whole series of other areas of analysis. You can do audit trading, exactly what that person did during that day. So you can actually evaluate how well they're using the system. And then there was another project where I actually worked with a bunch of undergrads and postgraduate students looking at, hey, what if we just threw it all away and looked at it completely differently? And so what if we use Elasticsearch as our primary data store? And we put a lot of thought into what's an appropriate object model, and we use a smart client technology on the front end to render all of that stuff. So we used React Native on the front end, Elasticsearch on the back end, and we're able to create a proof of concept mobile version of the support for product. And it ran like a cut snake. So that's, the company's not in a position to do anything with that for some time, but again, I was very happy with the results we got out of it. And so that was one of the questions that I've been asking myself. Is Elasticsearch ready to be used as a primary data store for a content management system? Can we actually rethink how we do a content management system using something like Elasticsearch as that primary data store? And the answer is, I believe, yes.
I think to some extent it depends on, it really depends on how much writing you do to Elasticsearch. If you write it once and then you do a lot of reading, then yeah, Elasticsearch can no SQL database, so that you could use that. But if you have a writing and you keep updating your documents a lot of time, then it's already expensive here. This already depends, but does it do?
Depends, yeah.
And then if you have a lot of join, you know, the point is in the Elasticsearch, if you have a lot of nested documents and
Yes.
that you want to have this, you want to get them back, and yeah, it might be a bit difficult because
It depends on the degree of, as you said, the cross relationships.
yeah.
If there's a lot of cross relationship information you need to manage, it's probably not.
But you can always denormalize and index it.
You can denormalize, or you can use hybrids. You can use Elastic as your document object store, and you can use a relational database for all the related ancillary information. I think it's probably time that we can start to rethink how we do content management systems.
Because it's all depends on what you're exactly looking at. But for
Exactly.
content management, I think yeah, because it's all about text, all about searching,
That's
all
right.
about finding.
Exactly.
It's
And your
the
primary, you know, one of the things that I've been thinking about a lot is in your traditional content management systems, they have these notions of hierarchy. Well,
the document.
yeah, that's right. The world is moving towards search as your platform for accessing information. So you don't need to store information in hierarchies. You can use a canonical representation to manage that sort of information, where that's metadata associated with the document. And if you look at some other Microsoft SharePoint, they use tags, nested tags. So there are other ways of representing that hierarchical information and managing hierarchical information. There's trade-offs. There are actually trade-offs. But I think we're at that
You can
threshold.
implement that like searching based on hierarchy, yet it's not right away from Elasticsearch. You
That's
have
right.
to really understand how Elasticsearch manage parent child queries, and then use multiple or nested queries with that one.
We're supposed to get home now?
Let that be done. So look, you know, there was just some other things. Just summing it all up, we were very happy with Elasticsearch. Everything that we wanted to do, we were able to do. And it's positioned the product, it's really kind of future-proof the product for us. So, you know, I've been really happy with it. And I keep studying, you know, all the latest and greatest things that are going on Elasticsearch. For example, the watches, alerts, and notifications. That's a really interesting. There's lots of things you could do with that. So that's our journey.